Hello, welcome to my another tech video. In this video, I'm going to elaborate briefly about one of the important topics in object-oriented programming, which is called solid principles. So, a developer should follow these principles to write a manageable, maintainable, and flexible code. So, I'm going to discuss briefly each principle so that developer can grasp an idea about each principle and how to follow these principles in their code. First, S for single responsibility principle. And the short definition is a class should have only one reason to change, meaning it should have only one responsibility. That means when a developer write a class, they should give this class a single responsibility. So they should not actually make this class full of responsibilities of many types. So a class should have a single responsibility. For example, a customer class should handle only customer related job. For example, customer basic information or address, etc. It should not handle the customer leave information, customer payroll, other things. So for the customer basic information and customer very specific information, you should create this class and should not make this class fat to perform other responsibilities. Open closed principle, or for open closed principles. So the definition of this open closed principle is it should open for extension and closed for modification. So, which means a class should not be modified. It should remain open for extension. For example, in the picture, you see that a payment processor class actually processing a payment of different type. And if another type of payment needs to be implemented, then the payment processor class needs to be changed to integrate that new payment type. In this case, crypto payment type. So in the right side, you see that to implement the open closed principle, you can create a separate class called crypto payment. And this class will implement an interface called payment strategy, and that interface will have two methods. For example, supports which payment should it support, and then the payment method itself, the pay method. So in the payment processor class, we are declaring a list of type payment strategy interface. And we have actually populated different type of payment in the pay method. So here you see that the strategy list actually injected the payment to its interface, and we are passing different type of payment in this same method, and based on the filter, it is actually implementing the payment. So the concrete notification or note is that you should not modify your existing class because that is error prone. Rather, you should write the class in such a way so that a particular type of object is sent to that class, and based on the type of the object, that particular class performs some operations. Third, L for Liskov substitution principle. It is stating that objects of a derived class should be substitutable for objects of the base class without breaking the program's correctness. Here, you see that a rectangle class is extended by square class. And when you implement the print area method and call the area, the value is changing. based on the types of classes we pass. Rather, if you write a class in such a way that the derived class substitutes the base class and call the method of the base class, then you should not change your value. I can say another example. Let's say you have an apple class and you have a method and it is returning apple as a string, and another class, let's say orange, and it is extending the apple class as a base class, and it is using the method of the apple class. Then in the client, if you actually call the base class method, then it will send you orange, which is not right. You should only return the apple when the apple object is passed and orange when the orange object is passed. In the right side, you see that the class rectangle actually following the LSP principle. Here we are setting the width, setting the height, and we are actually calling the area method and expecting the desired output. Objects of a superclass should be replaceable with objects of a subclass. If S is a subtype of T, then objects of type T may be replaced with objects of type S. Interface segregation principle. It is stating that you should not populate one interface with all the methods that a particular client will not use. You should segregate your interface in separate small interfaces for particular client. Here you say that in the worker interface, we have all the methods, and robot is not using all the methods of the worker, whereas bird is not using all the methods of the worker, but it is implementing worker. This is not the right way if you want to follow the interface segregation principle. In the right side, you see that you are defining different interfaces with very small number of methods, and you are implementing each particular interface for the related class. Here robot is implementing worker, and because it only needs the work method. Fish is implementing worker, eater, sleeper, and swimmer because fish needs to swim, fish needs to eat, and also the sleep method. So clients should not be forced to depend on interfaces and methods they do not use. It promotes loose coupling. Dependency inversion principle. Dependency this is the last principle, and it states that high-level modules should not depend on low-level modules. Both should depend on abstraction, and abstraction should not depend on details, which is stating that here in the left side, we have a order service. This is a high-level module, and there is a class, MySQL repository, which is a low-level module. You are watching there, the high-level module is strictly coupled with the low-level module, which is not actually following the dependency inversion principle. Rather, in the right side, we have a high-level module, order service class, and we have an interface which is acting as an abstraction layer, and it is called order repository, and it has two methods. And in the low-level module, it is implementing the interface, the abstraction layer. Here in the PostgreSQL, it is also implementing the abstraction layer. So we have now two low-level modules that are depending on the abstraction layer. And high-level module will use that abstraction layer to use the low-level modules. Later, I will implement each of these principles with code so that the concept becomes more clear. So here, high-level modules should not depend on low-level modules. I have already mentioned this, and abstraction should not depend on details. Details should depend on abstraction. I hope you have understood the solid principles, and every developer should implement and keep in mind while writing their code.